Hi again, Samar here. Welcome back to Go DevOps. If you joined us in the first episode, you now know what a container is and why it's central to modern DevOps workflow. So today in the second episode, we're answering a question I get a lot. So why are containers so lightweight compared to virtual machines? So we'll break it down step by step using examples, visuals, and real-world comparisons. So no stress if you're new to this. It's made to be beginner friendly, and let's go. Let's start our new episode. So let's take a side-by-side look at two different architectures. The one on the left is for virtual machines and the one on the right is for the containers. So with virtual machines, each application runs inside its own virtual environment, so complete with its own operating system, binaries, and libraries. And that means duplications everywhere. So each virtual machine carries a full operating system that adds weight, slow down startup time, and eats up system resources. So below all that, you need an hypervisor to simulate hardware, and that sits on the physical server. So now compare that to a container. So instead of duplicating the entire system, containers share the host operating system kernel using a container engine. So each component includes just what it needs. So the code, the binaries, the required libraries, and nothing more. So this makes containers lightweight, fast to start, and far more efficient. So the key difference isn't just technical, it's really concerned about the architecture. So virtual machine isolate everything, even what doesn't need to be isolated, and containers share intelligently to maximize efficiency. And that's why containers scale faster, use fewer resources, and enable smoother workflows. Now let's see how this efficiency actually impacts your development and deployment pipelines. Uh, First of all, let me give you a simple analogy to make the difference between virtual machines and containers crystal clear. So a virtual machine is like a separate house. So each house has its own walls, plumbing, electricity, and heating system. It's fully independent, which is great for isolation, but it also means a lot of duplication and overhead. So every house takes up more space, uses more materials, and costs more to build and maintain. So even if they serve for the same purpose. Containers is more like an apartment building. So each apartment has its own private living space, but they all share the same walls, plumbing, electricity, elevators, and core infrastructure. So it's more efficient, more compact, and still completely functional and secure for each tenant. So that's how containers work. They share the same operating system kernel, but each one runs its own app with just what it needs and nothing more. So containers are like smart apartments. They maximize resource sharing while keeping things isolated and safe. And that's why they're lightweight, fast to start, and idle to modern software delivery. So now that you have the image in mind, containers are smart shared apartments, let's break down why they are considered lightweight step by step. So there are four main reasons, and each one helps explain what makes containers faster, smaller, and more efficient than virtual machines. So let's start with the instant startup. So the containers launch in about half a second to 2 seconds, and that's almost instant, especially compared to virtual machines, which can take between 30 seconds to 2 minutes just to boot. And why is it so fast? Because containers don't need to load an entire operating system. They start with just what your app needs and nothing more. So this makes container perfect for real-time scaling and fast deployments. For the memory and CPU usage, they use way fewer system resources. So a typical container use only between 100 to 300 megabytes of RAM, while a virtual machine needs around 2 gigabytes or more just for the operating system. And the same goes for CPU. So containers are lightweight because they skip the overhead of running a full operating system, and that means you can run many more containers on the same machine, which is great for saving cost and maximizing performance. Lightweight packaging, so containers images are small, so on average a container image is between 50 to 300 megabytes, and a virtual machine image is usually between 1 to 5 gigabytes, because it includes an entire operating system, and containers only carry the essentials, so your app, its dependency, and a minimal runtime environment. So think of it like packing light for a weekend trip, and for the virtual machine is more like bringing your whole house. So less to move, less to store, and faster to deploy. And finally, we have the shared operating system kernel. So containers share the same operating system kernel, and instead of each container bringing its own operating system like a virtual machine, all containers on host run on the same Linux kernel. So this reduces duplication and improve performance, so especially around system calls. Everything runs more efficiently because the heavy lifting is done once and shared. So these are the 4 reasons why our containers are so lightweight compared to virtual machines. Let's now take a real-world example to see why containers become the standard for running modern applications. So on the left, you see a traditional setup using a virtual machine. So each virtual machine runs a full operating system with a lot of duplicated resources. On a single host, you might be able to only run like 2 or 3 apps. And on the right, we have containers. So here you can run between 8 to 10 microservices on the same machine, because containers are lightweight and share the host operating system kernel. And that efficiency is a game changer. Containers start faster, use less memory and CPU, and let you pack more services per server. And this is exactly why modern architectures, especially microservices, are built on containers. So they let you run isolated services that are easy to deploy and update and scale independently. So from startup to tech giants like Netflix and Google, containers power the backbone of global scale systems. So we have more apps for less cost and greater control, and that's the container advantage in real life. So one of the first questions people ask when learning about containers is, are they really isolated? After all, they don't run a full virtual machine. So surprisingly, the answer is yes. Containers are very well isolated, but instead of simulating an entire machine, they rely on the operating system itself to provide that isolation. So 2 key Linux features make this possible. It's the namespace and the C groups, the control groups. So the namespace, they give each container its own view of the system. So its own files, processes, users, network stack, and from inside, it feels like a complete system, even though it's just a lightweight slice of the host. And the C groups manage how much CPU, memory, and other resources each container can use. So they keep containers from stepping on each other's toes and help protect system stability. So even though containers don't spin up a full operating system, they still offer a strong isolation fast, efficient, and secure enough for real-world use. And this is what makes containers so powerful in cloud infrastructure, in CI/CD pipelines and microservices. So we have an OS level isolation without the bulk of the virtual machines. So what should you take away from today's episode is why are containers considered so lightweight, and why does it matter? So first of all, containers don't run a full operating system for every app, unlike virtual machine. They all share the same operating system kernel, which dramatically reduce overhead. Second of all, they boot up almost instantly, so no need to start a full operating system. And whether you're scaling up a microservice or deploying in CI/CD, speed matters, and containers, in this case, deliver in the almost instantly. And third, they use very little memory and CPU, because there is no extra operating system, so they leave more resources available for your applications, and that means you can run more apps on the same host. Containers are efficient because they share what can be shared, especially the kernel, without compromising or on process isolation. And finally, their packaging is optimized, so containers images are small, layered, and reusable, and this makes them easy to store, fast to deploy, and simple to update. So in short, containers give us speed, efficiency, and consistency, all in a lightweight format designed for modern software delivery. So thanks so much for watching today's episode, and I hope the concept of why containers are lightweight makes a lot more sense now. So if this video helps you, go ahead and give it a like, share it with a teammate, and subscribe so you don't miss what's coming next. So in the next episode, we'll dive into the internal architecture of a container. So layer by layer, we'll explore how it actually works in practice. And if you've got any container topic you're curious about, let me know in the comments. I really read every single one of them. And see you in the next episode.